Alright, so now we are going to talk about rational expressions. So in rational expressions, we are going to talk about simplifying and other stuff. So rational expressions can be written in the form p over q, where p and q are both polynomials and q should not be equal to 0. So because if we divide a number with 0, then it becomes indeterminate. Alright, so examples of rational expressions is shown here. So that's 3x squared plus 2x minus 4 over 4x minus 5. We also have another example there and another example there. So to evaluate a rational expression for a particular value, substitute the replacement value into the rational expression and simplify the result. Example. So evaluate the following expression for y is equal to 2. So here in our example, you have a rational expression y minus 2 over negative 5 plus y. So we are going to simply substitute y to negative 2. So also here, substitute y to negative 2, which gives us to negative 2 minus 2 over negative 5 plus negative 2 is equal to negative 4 over negative 7, which will be equal to positive 4 over 7. So in the previous example, so what would happen if we try to evaluate the rational expression for y is equal to 5? So we are going to use the same example, the same polynomial, but different y value. So change y to 5, you will have 3 over 0, but the expression is undefined since a number divided by 0 is undefined. So undefined rational expressions, we have to be able to determine when a rational expression is undefined. A rational expression is undefined when the denominator is equal to 0. The numerator being equal to 0 is okay since 0 divided by any number is 0. Alright, so find any real numbers that make the following rational expression undefined. Example, 9x cubed plus 4x over 15x plus 45. So this is undefined when 15x plus 45 is equal to 0. Right? So the expression is undefined when x is equal to negative 3, because if we multiply x with negative 3, negative 3 times 15, that's negative 45, plus 45, that is 0. Therefore, making the expression undefined. So simplifying a rational expression means writing it in lowest terms or simplest form. So we have learned already how to simplify, how to factor rational expressions to simplify. So to do this, we need to use the fundamental principle of rational expressions. If p, q, and r are polynomials and q and r are not 0, then pr over qr is equal to p over q. Simply cancel r, no? Which makes it p over q. To simplify a rational expression, we need the following steps. Completely factor the numerator and denominator. Apply the fundamental principle of rational expressions to eliminate common factors in the numerator and denominator. So let us be careful. Only common factors can be eliminated from the numerator and denominator. Make sure any expression you eliminate is a factor. Example, x plus 3 over x plus 3. You can cancel out x plus 3 since numerator and denominator are common. Let's have an example to simplify the expression 7x plus 35 over x squared plus 15. You can pause this video and try it in your notebook. So, we have a common here in the numerator as 7, because if you simplify 7 multiplied by x plus 5 over the denominator also, the common here is x. Therefore, you can cancel x plus 5 and x plus 5, making the expression as 7 over x. Another example, x squared plus 3x minus 4 over x squared minus x minus 20. So, what we have learned in factoring is a very big help, since it will help you how to simplify expressions in rational terms. So here, the factor for x squared plus 3x minus 4 would be x plus 4 times x plus 1. And the factor for x squared minus x minus 20 is x minus 5 and x plus 4, making x plus 4 common here. Therefore, we can cancel them out, making the answer x minus 1 over x minus 5. Another example is 7 minus y over y minus 7. The question is, can we easily cancel it out? No, we cannot cancel it out yet. We have to make way to make both numerator and denominator similar. How do we do that? So, we multiply negative 1 with y minus 7 because that would be negative y plus 7, which would be similar to the original term. Making y minus 7 a common term, you can cancel them out, making your answer as negative 1. So how do we multiply and divide rational expressions? So when p, q, and r and s are polynomials with q is not equal to 0 and s not equal to 0. So therefore, p q over q times r over s would be pr over qs. So note that after multiplying such expressions, our result may not be in simplified form, so we use the following techniques. Multiplying rational expressions. Number 1. You factor out the numerators and denominators first. Then, multiply the numerators and multiply the denominators. Then, simplify or write the product in lowest terms by applying the fundamental principle to common factors. To further understand, let's have an example. Let's multiply the following rational expressions. So that's p over q times r over s. That's pq over rs. Therefore, this will result to 2 times 3 times x times 5 times x over 2 times 5 times x times x times 2 times 2 times 3. So why do we do that? It's because we can cancel out common terms to find the very simplest form of the answer. So the answer would be 1 over 4. Or you can simply multiply 6x squared times 5x. That would be 30x cubed, right? All over 10x cubed times 10x cubed times 12, that would be 120x cubed. So simply you can cancel x cubed and then 30 over 120, that is simply 1/4. Okay? Another example. Multiply the following rational expressions m minus n squared times n over m plus n times m squared minus mn. So we all know that m minus n is equivalent to m minus n times m minus n, right? And m squared minus mn, the common term for this one is m. So, you can factor that out. Then, you can cancel m minus n and m minus n. And you also can cancel m and m. Therefore, making your answer as m minus n over m plus n. Alright. So, when dividing rational expressions, when p, q, r, and s are polynomials with q is not 0 and s is not 0 and also r is not equal to 0, therefore p over q divided by r over s would be simply p over q times s over r. So we all know that this is the method when we divide even in fraction. So yes, just follow the rule in dividing fractions. Not fractions with, for example, 1/2 divided by 3/4. So simply that's 1/2 times 4/3. So when dividing rational expressions, first change the division into a multiplication problem where you use the reciprocal of the divisor as a second factor. Then treat it as a multiplication problem. You factor, you multiply, and then the last one, which is very important, simplify. Because if your answer will not be simplified, your answer might be wrong or it might get lower points in scores in your exam. Example, you divide the following rational expression, x plus 3 squared over 5 divided by 5x plus 5 over 25. So we are going to reciprocate this one and change divide to times. Alright, then we are going to simplify 5x plus 15. The common term here is 5, and 25 divided by 5, that's also 5, making your answer x. So in adding and subtracting rational expressions with the same denominator and least common denominators, so let us apply the same rule when you add the basic fractions, no, that we know during elementary and high school and your senior high school days. So here, the denominator is common, so therefore the LCD is just 2p plus 7, and then 2p plus 7 divided by 2p plus 7, so that's 1 times 4p minus 3, so that's 4p minus 3, and then 2p plus 7 divided 2p plus 7, and then times 3p plus 8, that would be 3p plus 8, making our answer as 7p plus 5 over 2p plus 7. Another example, so very easy. Again, they have the same denominators, so our LCD would be y minus 2, making it 8y minus 16 over y minus 2. That would be equal to 8 times y minus 2 over y minus 2, making our answer as 8. So what happened here is y minus 2 divided by y minus 2, that's 1 times 8y, so that's 8y. Y minus 2 times y minus 2, that's 1 again, times 16. So copy the sign, so that's minus 16. Another example. So again, the same denominator, just copy. Then your answer would be 3 over y plus 5. So remember always to simplify your answers for you to get the correct answer, or for you to get the simplest term in your answer. Alright, so to find the least common denominator, we have to factor out the given denominators. Take the product of all the unique factors. So each factor should be raised to a power equal to the greatest number of factors that factor appears in any one of the factor denominators. Example, we are going to find the LCD of 1 over 6y and 3x over 4y plus 12. So what is the LCD for that one? So in 6y, the factor is 2 and 3y. In 4y plus 12, that is 4 and y plus 3. So making it 2 squared and y plus 3. So you can see here that 2 is common, right? So the LCD is 2 squared times 3y times y plus 3, or 12y times y plus 3. Another example. So here, we are going to find the LCD before we can add or subtract the following. So it would be hard for us to get the answer without knowing the LCD, since the denominators are different. So to find that one, we need to factor out the first term and the second term. So factor for the first polynomial's denominator is x plus 3 over x plus 1, and the factor of x squared plus 10x plus 21 would be x plus 3 and x plus 7. So therefore, our LCD is, you copy x plus 3 and then x plus 1 and x plus 7. Alright, another example, find the LCD of the terms. So these are your LCD. So factor 5x squared minus 5, that's 5 times x plus 1 and x minus 1. And for x squared minus 2x plus 1, that's x minus y squared. So the factor would be 5 times x plus 1 times x minus 1 squared. Alright, another one. So both of the denominators are already factored. So our LCD for this one would be x minus 3 and 3 minus x. So to change rational expressions into equivalent forms, use the principle that multiplying by 1 or any form of 1 will give you an equivalent expression. Example, rewrite the rational expression as an equivalent rational expression with a given denominator. So 3 over 9y to the power of 5. How are we going to do that? So simply 3 over 9y to the power of 5, multiply it by 8y4 over 8y4. So why did we multiply it by this? Because this one is just equivalent to 1, making our answer the same. Therefore, our answer would be 24y4 over 72y9. So, in equivalent expressions, we're going to look for expressions that are similar to the expressions to the original expression. So, it's just the antonym of factoring out, because if you're going to simplify this term here, you will arrive at the original term. Alright, so different denominators. So we are going to use what we have learned in finding the LCD. So in unlike denominators, we are going to have the rule, find the LCD of all the rational expressions. Then we are going to rewrite each rational expressions as an equivalent one with the LCD as the denominator, add or subtract numerators, and write result over the LCD, and simplify rational expression if possible. So that is very important. And also, let me add my rule in finding the final answer, box your answers. Example. So add the following rational expressions. So you have the denominators as 7a and 6a. What would be the LCD? So simply, LCD would be 6 times 7a. So making it 43a, right? Or 42a. So 42a divided by 7a, okay, that is 6, right? Or you can just follow this one, 6 times 7a plus 7 times 6a. So it's no problem, no? Then you divide it with this one, with the term here. So 6 times 7a divided by 7a, you will have 6 times 15, that is 90, right? This one as well. So actually, it's just similar. So if I were to solve this one once again, you have, how do I write? Hold on. Can I write? Wait. Alright, so yeah, that would be 42a divided by 7a, that's 6a, right? Or 42a divided by 7a, that's 6 times 15, so the same. 42a divided by 6a, that's 7 times 8, that's the same, making our answer as 90 over 42a plus 56 over 42a. So that would be 146 over 42a, and then we are going to simplify. That's 73 over 21a. Another example. So what is the LCD for this one? LCD for that one would be 2x minus 6 and 2x minus 6. So how are we going to solve that one? So that would be 8 over 2x minus 6 all over 4 over x minus 3. So guys, what we did here is we just multiplied this one by -1 so that we will have similar denominators here, and then the sign will be changed from negative to positive. Alright, so that's it for rational expressions. Thank you so much for listening. I hope you have learned something from me today. And I hope that you will also do your part as students. You read the Sims, you read more books, solve more problems for you to ace your exam. Thank you, and God bless you all. Have a good